my PU2 aspirants, so we know that your final PU board exams are very closer, and to help you with your preparation, today I have come up with this PU2 chemistry marathon series where we are going to discuss all the 5-marker questions from all the organic chapters. Okay, so these 5-marker questions are very predictable. Okay, they are generally mostly repeated. Somewhat they will twist and turn the questions. Overall, the concept from which the 5-marker questions are asked is remaining the same from many years, right? So I have analyzed the last 5 to 10 years of papers, model papers, even all the districts pre-board papers, and I have given you the most important repeated 5-marker questions that you can expect in this final examination. Okay, so what is your task now? You have to sit with a notebook and a pen. You have to note down all the questions and you have to try to answer them with me. If you have doubt in any question, do not worry, I'll be telling you the solutions as well as how to represent the answer in your exam. Okay, so let's get started with this. Okay, yes, so if I see, the 5-marker questions are asked in section D, right? And in section D you will have 6 questions, out of which you have to attempt any 4. So you have haloalkanes and haloarenes, from which one question will be asked, alcohols, phenols and ethers, from which one questions will be asked, aldehydes, ketones and carboxylic acid, from where you can expect 2 questions, amines 1 question and biomolecules 1 question. Okay, so now let us go for the first chapter. Okay, so now what I assumed is, in this 5-marker question, it will be either in the form of 3 plus 2 or mostly in the form of 2 plus 2 plus 1. Okay, generally like these questions are asked. And in haloalkanes and haloarenes, the most important from where this 3 mark or 2 mark can be asked is your SN1 and SN2 mechanism. Okay, so for 5-marker questions from this chapter, you must prepare SN1 and SN2 mechanism. Okay, so let us see the first question here. Write any 3 differences between SN1 and SN2 reaction mechanism. Identify A and B in the given reaction. Okay, so these 3 differences will carry 3 marks. Identifying A and B will be carrying another 2 marks. Okay, so if I see here the first differences, you can write any 3 points. I have mentioned these 3 points, that SN1 reaction occurs in 2 steps, SN2 occurs in 1 step. Here carbocation intermediate is formed, here only transition state is formed. Here it follows first order kinetics, here it follows second order kinetics. Okay, now coming to the identify the A and B in the given reaction. So if you see here NaNO2 plus HCl, this will give you aniline and this one will give you benzene disonium chloride, right? N2 plus and Cl minus. Now for bromobenzene, you can use Sandmeyer reaction or Gattermann reaction. So I will use Br2 in presence of, I will use Sandmeyer reaction. So I can write Cu2Br2 in presence of CuBr. Right, so you can write Sandmeyer reaction or Gattermann reaction reagent you can consider. Okay, next coming to this one will give you 3 plus 2 5 marks. Next we'll see second question. Write the mechanism involved in the conversion of 2-bromo 2-methyl propane to 2-methyl propane 2-OL. Which type of solvent favors this type of reactions? Okay, so you have this mechanism 2 marks, this question 1 mark, total 3 marks. Then enantiomers and racemic mixture definition you will get 2 marks. Okay, so let us first write the mechanism here. So whenever conversion is asked, okay, first mention what is getting converted to what. You have 2-bromo 2-methyl propane. So I can write like this, 2-bromo 2-methyl propane, and you want to convert it into 2-methyl propane 2-OL. Okay, so this is what I have here is 2-bromo 2-methyl propane. Okay, and this side I have 2-methyl propane 2-OL. Okay, so step number 1 here is what? Formation of carbocation. Okay, so if I want to form this carbocation, how can I write like this? See, CH3 whole 3 CBr. So here this Br will go out and we will get CH3 whole 3 C plus. Okay, this is your step number 1. Next, what will happen in step number 2? Step 2 involves attack of nucleophile, right? So here what will happen? CH3 whole 3 C plus OH minus is there. This one will attack here. We will get okay. So now you can see that what you have to do, first you have to write the reaction that is being asked, then you have to mention the step name and the mechanism, step name and the mechanism. So this one will give you 2 marks. Next, which type of solvent favors this type of reaction? So we know that this is SN1 mechanism. So here you can mention also SN1 mechanism. Okay, this also you should mention. Now, which type of solvent prefers this type of reaction? Polar protic solvent. We need polar protic solvents. Okay, so this total will give you 3 marks. Next, to define enantiomers and racemic mixture. So what are enantiomers? Enantiomers are the stereoisomers which are non-superimposable mirror images on each other. Next, what is racemic mixture? A mixture containing 2 enantiomers in equal proportions will have 0 optical rotation, as the rotation due to one isomer will be cancelled by the rotation due to another isomer. Such a mixture is known as racemic mixture or racemic modification. Okay, so this is the definition. This will give you 2 marks. Okay, so total 5 marks we have got here. Next, we will see a question. Yes, ABC type question can also be asked. Very popular question. A primary alkyl halide C4H9Br. So I'll first draw a scheme for this one. Okay, so I have one A whose formula is C4H9Br. Reacted with alcoholic KOH to give you compound B. Okay, reacted with alcoholic KOH to give a compound B. Now compound B is reacted with HBr to give C. Okay, it is reacting with HBr to give C, which is an isomer of A. Okay, so what is the relation between A and C? A and C are isomers. Okay. Next, when A is reacted with sodium metal, it gives compound D. Okay, when A is reacted with sodium metal, it gives compound D, and if you see that here the exact number of carbon has doubled, right? C8, C4 and C8. So that I can guess that this is a Woods reaction. Next, which is different from the compound formed when N-butyl bromide is reacted with sodium, which is different from the compound when N-butyl bromide. So if you just directly take N-butyl bromide, then you will get, if you do its Woods reaction, you will get octane. So it is not octane structure. Okay, it is something different from that. So that means this A is not N-butyl bromide, it must be an isomer of N-butyl bromide. Okay, give the structural formula of A. Okay, give the structural formula of A and write all the equations for all the reactions. So if you see, we have to give the structure of A, that is one reaction, that will give me 1 mark. Here one reaction, here one reaction, here one reaction. So 1, 2, 3, 4 reactions I have to write. Okay, okay. Let's start then. So if you see, I can take, it is not, so one thing I got that C4H9Br is not N-butyl bromide, right? So what you can have very simple structure of this one. So let me take like this, CH3 1, 2 CH2 and Br. I can take like this as A, suppose. So what is this one? 1 bromo 2-methyl, okay, 1-bromo 2-methyl propane, right? Now what is there here? If you take alcoholic KOH, so what will happen? A double bond will form here, so I will get CH3, okay, here H, here and Br will be removed, so double bond CH2, okay, that is one reaction I've got. Next, if you treat it with HBr, okay, so what will happen? Markovnikov's addition will take place, right? And here we will get CH2, one second, okay, so here I have CH3, CCH3, CH2, Br, okay. So now this is your B, okay, this is C and this is A. So I can say that A and C are, okay, so sorry, here we have to follow Markovnikov's rule, right? So bromine will come here and H will come to this carbon, right? So yes, A and C are definitely I can say isomers, because here bromine is present in first carbon, here bromine is present in second carbon. Next what we have got? I have got C. After that, if this one is reacting with sodium ether, so just what will happen? A replica of that will form. So I can write like this, CH3, okay, and this side it is again this one, okay. So I can say that 2, 3, I can make a long carbon chain of 1, 2, 3, 4. Anywhere we make it will get 6 carbon only. So we will get this as the product, that is your D, okay. Yes, so this is the answer. I hope you have got it. All the reactions have been mentioned and the structure of A is also given to you, okay. Next we'll go to alcohols, phenols and ethers. So I have taken very few questions from haloalkanes and haloarenes, because the question will be mostly from SN1 mechanism, and the rest 2 marker question can be anything. So for that you can refer to my 2+3 marker videos, where I have given you all the possible 2+3 marker questions, so that can be incorporated there. Now going to the next chapter, that is alcohols, phenols and ethers. So let me tell you, in alcohols, phenols, ethers also it is generally 3+2, okay, and this 3 mark is a mechanism based question, okay, and this chapter has 3 mechanism. The first one is alcohols to alkenes, the second one is alkenes to alcohols, and the third one is alcohols to ethers, okay. So these 3 mechanisms, please prepare properly. All the 3 mechanisms has 3 steps, so anything can be asked in this 3 marker first part, okay. So let us see the first question. Explain the mechanism of dehydration of ethanol to ethene, okay. So alcohols to alkenes. Identify A and B in the following reaction. So first let us do this one, then we will go to A part, okay. So if I see this is your Salis O minus A, it will react Riemer-Tiemann reaction. So the product here will be OH and, okay, sorry, not Riemer-Tiemann Remus, it will get salicylic acid, okay, sorry, not Riemer-Tiemann, it is your Cole's reaction, right. So we will get here salicylic acid. Next what happens here? This one is breaking, HI is breaking. So if you can see here that this part is a tertiary group, so here carbocation will form, so I minus will attack here. So what will be this one? B will be CH3 whole 3 C and I, okay, clear? Yes, fine. Now we will do the mechanism part, ethanol to ethene. So you have to write the step number and the mechanism, okay. So what is the first step? Protonation or formation of protonated alcohol. So from alcohol in the medium, acidic medium, this O plus H gets protonated, means one H is added here, that is O plus H2. Second method or the second step is formation of carbocation. You just have to write this heading, okay, this part is not required. So here you have to remember that this is the slowest step, so you should write the slow part in the mechanism. So what will happen, this O plus H2 is there, it will break to give you a carbocation. The second one is the formation of ethene, okay. So here what will happen, this H plus will come here and we'll get a ethene and H plus is produced, okay. So this mechanism you have to prepare thoroughly, okay, very, very important question. After that, we'll go to next question. Identify A, B and C in the following reaction. So you can see here reaction based question. So we have OH plus Br2. So if you know that all the bromines will get replaced here, right? So we will get OH, Br and Br, okay. Next here phenol plus zinc will give you benzene, right? And here C2H5OH plus CNA will give you C2H5ONA plus H2. So C is what? H2 gas. So this is your reactions of alcohols with metals. So it will behave as an acid, it will give you salt and hydrogen gas. So A, B, C we have found out. Next what we have to do, how to prepare phenol from aniline, okay. So here you can see diazonium salts are hydrolyzed to phenols by warming with water or by treating them with dilute acid. So you have to take aniline, aniline is converted to benzene diazonium chloride by treating it with HNO2 or nitrous acid. After that you just take warm water, you will get in the this one will be replaced with OH group, okay. Yes, next we have explain the mechanism of dehydration of alcohols into ether. I told you 3 mechanisms. Second mechanism is here. So yes, you can see here first what happens, the same thing, protonation of alcohols takes place to to give you O plus H2. So here it is like this, okay. Then what happens, then there is attack of another alcohol on this alcohol. You can see now this carbon is electrophilic in nature, this oxygen is having lone pair which is nucleophilic in nature. So this one attacks on this one and this one goes out, so we get this one. And the third step is your simple deprotonation, H plus goes out and we get the ether. Next question is what we have, how anisole react with acetyl chloride. So anisole is your benzene with OCH3 group, right? So it is an ortho para directing group. So what will happen, the acetyl group will go and attach at the ortho and para position, okay. So you can see here that anisole undergoes Friedel-Crafts acylation reaction where acyl groups are attached at the ortho and para position by reacting it with acyl halide in the presence of anhydrous AlCl3 as a catalyst. So you can see here OCH3 CH3 Friedel-Crafts acylation reaction, CH3COCl with anhydrous AlCl3 will give you COCH3 here and COCH3 here, okay. That is your alpha ortho and para products are formed, right? This is very easy question. Next, explain the mechanism of hydration of alkenes to alcohol. So I told you 3 mechanisms, is the third mechanism. Next, complete the following reaction. Okay, so this first let us do this part. So addition of H2 and H plus follows Markovnikov addition. So what I will get here, CH3 CH2, here we have OH and here it will become CH3. This is A. Okay, now after this CrO3 is what? It is an oxidizing agent. A secondary alcohol will be oxidized to ketones. So what I will get, CH3 CO and CH3. Okay, so this is A and this is B. Now coming to this mechanism, you can see first what happens, alkenes are there, right? So alkene will react with protonated water to give you carbocation and this water is formed. Now on this carbocation, this O will attack again to give you this one, and finally there is deprotonation to get alcohol. So please, many students get confused in this mechanism from alkenes to alcohols and alcohols to alkenes. So be very careful, practice it again and again, see the book and write down each of these mechanisms 5 times, okay. Very, very important, must come questions, so do prepare. Next question, an alkene C3H6 reacts with H2 and H plus to give you compound Y. Compound Y further undergoes reaction with CrO3 and H2SO4 to produce compound Z. Write the IUPAC name of compound X, Y and Z. So if you write the IUPAC name correctly, you will get 3 marks, but you should also write the reactions. Okay. Next, which among the following have the lowest and the highest pKa value? Okay. So let us first see this one, C3H6. So if I see this is propene, right? CH3, CH double bond, CH2. Now if I, so this is X. Okay. Now if I treat it with H2O and H plus, so what will happen? You have to add water following Markovnikov's rule. Okay. So this one will add OH here and I will add H here. Next, after that, so this is your compound Y. Okay. Now after that, what will happen? You have to treat it with CrO3 and H2SO4. So what will this do? It will produce compound Z, where this one is oxidized. So we will have CH3CO and CH3. So you have to tell the IUPAC name. So what is X here? X is propene, okay, and Y is propane 2OL, okay, and Z is propanol. Okay. Now coming to, so this is answer number A. Next one, which among the following compounds have the lowest and highest pKa value? So this pKa value is little tricky. You should always remember that if highest acidic, or I can say a strong acid will have low pKa value, okay, and a weak acid will have high pKa value. Okay, strong acid low pKa value and weak acid will have high pKa value. Okay, now coming to this one, electron withdrawing group will increase the acidity, electron donating group will decrease the acidity. Okay, these two things if you know, now we can answer this question easily. Let's go for B. Okay, so now if you see here, nitrophenol, electron withdrawing group is there, definitely it is a very strong acid group or a very strong acid, so its pKa value will be lowest, right? So lowest pKa will be what? Lowest pKa will be para-nitrophenol. Okay, next we have phenol, okay, ethanol, and then we have cresol. So cresol, if you see, it is a cresol is like this, orthocresol, right? So it is an electron donating group. Okay, it will decrease the acidity. So what we will get here? Highest pKa value. Okay, one more thing. Sorry, just a minute. Ethanols. So the phenols have a very good acids compared to aliphatic alcohols. Why? Because in phenols the conjugate base is very stabilized. So if I just write down their acidity order, okay, then we can find the lowest and the strongest acid very easily. So see, if I just want to order them, so first one will be definitely para-nitrophenol, okay, next one will be phenol because it is a neutral group, no groups are attached here, and then I have orthocresol, right, where I have a electron donating group, and then I have phenol, then I have ethanol, yes, then I have ethanol, right. So what will happen? Ethanol, because it is least acidic, its pKa value will be highest. So highest pKa value will be for ethanol. Okay, clear? Next, question number 9. How is phenol prepared from benzene sulfonic acid? Write the equation. Then how anisole reacts with methyl chloride? What is the effect of electron donating group on the acidity of alcohols? Okay, so this is very easy question. How? Let us see first sulfonic acid, how it is prepared. That is your oleum method. So benzene sulfonic acid on heating with NaOH followed by acidification gives you phenol. So you have to take benzene, treat it with oleum, that is concentrated sulfuric acid. You get benzene sulfonic acid, then you have to treat it with NaOH, and in acidic medium you will get phenol. That is the first part. Next, how anisole reacts with methyl chloride. Okay, so yes, anisole, the same like Friedel-Crafts as alkylation takes place. Anisole undergoes Friedel-Crafts alkylation reaction where alkyl groups are introduced at ortho and para position by the reaction of alkyl halide in the presence of AlCl3 as a catalyst. So this one is your Friedel-Crafts alkylation reaction. Next, what is the effect of electron donating group on acidity of alcohols? So sorry, electron donating group increases the acidity. Sorry, in electron donating group decreases the acidity. Okay. Now one more important question that I have discussed in the 2 marker section that can be asked in the 5 marker section, that is your preparation of phenols, preparation of phenol from cumene. Okay. So please prepare this one properly. Okay, I have not discussed this one because I have discussed this in the 2 marker section, but yes, please prepare this one also. Okay, now moving to the next chapter, that is aldehydes, ketones and carboxylic acid. So from here, this chapter 2 questions will be asked. Okay, so there are so many questions that is possible, but yes, we will be focusing on the most important one. So the first one is the IUPAC name and Gattermann-Koch reaction. So see, again, if it is 3 plus 2 marker, the 2 marker can be any name reaction or any acidic group, order of acidity. Okay, or it can be any reaction, fill in the blanks type question, anything can be asked in this 2 marker section. So let us see the first one here. Okay, fine. Okay, so first you have to give the IUPAC name here. So this is ethanol, right? 2 carbon with the aldehyde group, so ethanol. Okay, next this one is 1,2 prop 2 EN Al, and this one is your ester, right? Here we have ethyl ethanoate. You can write like this. Ethyl ethanoate. Okay, so I have one group here, ethyl and ethanoate. Clear? Now coming to Gattermann-Koch reaction. So whenever any name reaction is come, first the statement and then the reaction. So benzene reacts with carbon monoxide and hydrogen chloride in the presence of anhydrous AlCl3 and traces of cuprous chloride to give you benzaldehyde. Very simple reaction. Just you have to write down what is the reactant, what is the product, and what is the reagent that is used in this particular reaction. Okay, next we'll move to write equations for the reaction between carboxylic acid and PCl5, reaction between formaldehyde and concentrated KOH, the formation of oxime from carbonyl compounds. Okay, next, among formic acid and acetic acid, which is more acidic? Give reason. So here when this type of question comes, first you have to write which is more acidic, that is 1 mark. Give reason is your 2nd mark. So let us first solve this one. So if you have carboxylic acid with PCl5, we'll get RCOCl plus POCl3 plus HCl. The next one, reaction of formaldehyde with concentrated KOH. So that is what? That is your Cannizzaro reaction. So if I have formaldehyde, okay, with concentrated KOH, okay, so that will give you an acidic salt, okay, and a alcohol. Okay, 1 carbon, one will be getting converted to as salt, another will be your alcohol. Next we have formation of oxime from carbonyl compound. So if I have carbonyl compound with oxime, okay, so what will happen? This H2O will be removed and you will get NOH. Okay, that is your oxime. Okay, next we have which is more acidic. So if you remember, what is the structure of formic acid? So if you see, this is formic acid, okay, and acetic acid is this one, right? Now when they will donate H plus, they will convert to acid. So here I will get O minus and O minus. So this is the conjugate base that is formed. Now the conjugate base means what? It is electron rich. You can see this CH3 group will donate more electrons. So what will happen? The electron density will increase and the conjugate base will be less stable. Whereas here there is no such effect. So I can write that formic acid will be more acidic. What is the reason? Because its conjugate base is more stable. Okay. So you can write down, first of all, you should write formic acid is more acidic, that is the first thing, because the conjugate base is more stable than the acetate ion. Clear? Now we will go to next question. Explain the preparation of carboxylic acid from Grignard reagent, give equation. So explanation 1 mark, give equation 1 mark. Explain the HVZ reaction with example, again the name reaction, definition and example, 2 marks. So first let us see here Grignard reagents. Okay, what is how Grignard reagents react with carbon dioxide, which is also called as dry ice, to form salts of carboxylic acid, which gives carboxylic acid after acidification with mineral acid. So if you see the reaction here, okay, I think I haven't put that reaction. Okay, I will put that reaction. So you can see what is HVZ reaction. Next one, HVZ reaction is those that carboxylic acid containing hydrogen, alpha hydrogen, reacts with chlorine or bromine in the presence of small quantity of red phosphorus to form alpha haloacids. So if you have this one RCH2COH and you react with X2, that is red phosphorus and water, this is your alpha hydrogen, right? So this alpha hydrogen will be converted to X. Whatever you have taken, is it chlorine, bromine, that will be converted to this one, okay, X. Now here the reaction I want to write down. Okay, yes. So what happens if we take Grignard reagent, that is RMgX, it reacts with CO2. Okay, now this one reacts here, so I will get here RMgX, and then if you do hydrolysis in acidic medium, you will get RCOOH. Okay, let us see the next question here. Write the general equation involved in the addition of ammonia and its derivative to the carbonyl group. So first of all, you can see this reaction takes place. Here what happens? Here this group attacks as a nucleophile on this one, this bond shifts here. So I will get an intermediate like this, and then there is rearrangement to give you this product. Okay, so this one is the first question. Explain Cannizzaro reaction with an example. So what happens here in Cannizzaro reaction? I can write like this. Option, I'll write answer B here. Okay, this is wrong. Okay, please eliminate this one. I'll write here answer number B. Some error is this one, I'll tell you. Aldehydes or ketones which does not have alpha hydrogen undergo disproportionation reaction, in presence of concentrated alkali to give alcohols and salt of carboxylic acid. Okay, that is your Cannizzaro reaction. You can write any example. So if I take one example, like I'll take benzaldehyde, okay, and if I treat it with concentrated NaOH, so what I will get here? COO minus Na plus, and I will get, okay, this is. Next, aromatic aldehydes do not answer to Fehling solution. So if you remember, in Fehling solution we get copper salt and alkali medium, right? So what happens, due to the presence of this alkali medium, this aromatic aldehydes undergo Cannizzaro reaction. Okay, they do not undergo this Fehling reaction. So that is the answer here. Aromatic aldehydes undergo Cannizzaro reaction due to the absence of alpha hydrogen in the presence of an alkali medium. Clear? So that is why they do not show the Fehling's reaction. Okay, next question. With respect to the structure of carbonyl group, give the following hybridization, number of sigma and pi bonds, and the geometry and bond angle. So if you see, carbonyl compounds are like this. Okay, so what is the hybridization? Carbon has 3 sigma bonds, so it has sp2 hybridization. Number of sigma and pi bonds, 3 sigma and 1 pi bond, and the geometry and the bond angle. So geometry, if you see, it is a in one planar, trigonal planar, and the bond angle is 120 degree. Okay, next explain the conversion of toluene to benzaldehyde by side chain chlorination. Okay, so here you can see side chain chlorination of toluene gives benzyl chloride, which on hydrolysis gives you benzaldehyde. You can write the reaction here. You have taken chlorine, you do side chain chlorination, that is you treat it with Cl2 and H nu, you will get CHCl2 here. After that you just do hydrolysis, you will get benzaldehyde here. Okay, next write the chemical reactions that affect the following transformations. Okay, first butane 1-OL to butanoic acid. Okay, so let me do A1. So butane 1-OL, write the chemical reaction. So I have CH3, CH2, CH2, OH. Butane 1-OL to butanoic acid. So I'll write like this: CH3, CH2, CH2, COOH. Okay, so what is the what I can say reagent required here? From primary alcohols to acids, so it is alkaline KMnO4. Okay, next we have second one, cyclohexene to hexane 1,6 dioic acid. We have cyclohexene to hexane 1,6 dioic acid. So this one also we have to use alkaline KMnO4. Okay, this will break this bond. The third one what I have is butanol to butanoic acid. So aldehydes to acid. So you can use any mild oxidizing agent. The best one is your Tollens reagent. So you can use like this: CH3 butanol to butanoic acid. Okay, so what is the reagent here? Tollens reagent. Okay, next explain Clemmensen reduction with an example. So what happens? The carbonyl group of aldehydes and ketones is reduced to CH2 group on treatment with zinc amalgam and concentrated HCl. This is known as your Clemmensen reduction. So you can write down the reaction with an example. Clear? Now we will go to next question. Explain the test to distinguish between aldehydes and ketones. Complete the following reactions. Among 4-nitrobenzoic acid and 4-methoxybenzoic acid, which is more acidic? Okay, so yes, so first of all, test what we can do. You can give Tollens test also, Felling's test also. So Tollens test, if I give aldehydes on treating with Tollens reagent gives a bright silver mirror due to the formation of Ag. And here also you need to add ketones do not respond or do not react. Okay, next complete the following. So here you have CH3COCl and you have anhydrous AlCl3. So okay, the Tollens reagent you can give the reaction also example, so that this one carries 2 mark. Next if I I'll do the B part here. One second. Yes, so what will be the product I'll be getting? You have here, it will be simple acylation, COCH3, and here what will happen? Oxime will form, H2O will be removed, and I will get here CH3 double bond NOH. Okay, next among 4-nitrobenzoic acid and 4-methoxybenzoic acid, which is more acidic? So you can see electron withdrawing group will always increase the acidity. So here nitro group is present. Nitro group is an electron withdrawing group, so definitely it will increase the acidity. So you can see here, first of all you have to write which is more acidic, that is 4-nitrobenzoic acid. Then you can explain why. So 4-nitrobenzoic acid is more acidic because of the presence of electron withdrawing group which stabilizes the conjugate base, whereas 4-methoxybenzoic acid has electron donating group which destabilizes the conjugate base. and hence it is less acidic. Okay. Next we will see question number 17. So here you have to fill in the blanks, 3 XYZ, that will give you 3 marks. Arrange the following in the increasing order of their acidity, that will give you 2 marks. Okay. So let us do this one quickly. So first, if you have Rx and you are treating it with MgBr, so that is your Grignard reagent, right? So what I will get here, I will get I can write like this, one second, I'll write like this. Here I will get MgBr, and at this meta position I have NO2 group. Now what will happen, CO2 is there, so this one will react with CO2, so this is your X. What will be Y? This one group will attack on CO group, so I will get here, yes, and here it will be NO2 group, okay, and COO minus, here it is MgBr. Next, if I do hydrolysis, what I will get? I will get here COOH, and here I will get NO2. Clear? So that is your X, Y and Z. Next, arrange the following in the increasing order of their acidity. So as you can see, here is an electron withdrawing group is there, so this will be more acidic. So if I number it, like if it is like this 1, 2 and 3, then you can see here donating group is there, so it is least acidic. So what will be the highest acidic? 2, then 1 and then 3. Okay, clear? Next, what is haloform reaction? Give an example. What is aldol condensation? Give an example. Name the product formed when formaldehyde undergoes Clemmensen reduction. Okay, so name reactions anywhere, where 2 marker question can easily be asked. So what is haloform reaction? Whenever you have this CH3CO group, okay, if this group is present, then only haloform reaction will take place, where you will get acid, salt of an acid, and this group will convert it to CHX3. Okay, so I'll explain here. You can see that aldehydes or ketones with at least one methyl keto group. Okay, what is this methyl keto group? This one, methyl keto group. Okay, are oxidized by sodium hypohalite. What is sodium hypohalite? NaOX. This is called as sodium hypohalite. Okay, are oxidized by sodium hypohalite to sodium salt of carboxylic acid and with 1 carbon less than the parent compound. The methyl group is converted to the halo form. So here whatever R is there, okay, so just let me write it as R. Okay, so what will happen? This group will get converted to an acid, and this group will convert it to CHX3. So let me give you an example here. You can see this one. So I have taken RCOCH3. Okay, with NaOX what will happen? You will get RCO O minus Na plus, and this CH3 gets converted to CHX3, where X is your chlorine and bromine or iodine. Okay. Next, what is aldol condensation, and give an example. So aldol condensation, if you need to have an alpha hydrogen, right? So you can see aldehydes or ketones with at least one alpha hydrogen undergo self condensation in the presence of dilute alkali to form beta hydroxyaldehydes or ketones. The aldol formed undergo dehydration to give you alpha beta unsaturated alcohols, aldehydes or ketones. So first of all, what we need to have one aldehyde in presence of dilute alkali, you will get one beta hydroxy aldol product. Now if you heat it, then what will happen? Here water will be removed, OH and H will be removed, and you will get a double bond here. Okay. Next, what is the question here? Name the product formed when formaldehyde undergoes Clemmensen reduction. Okay, so when formaldehyde undergoes Clemmensen reduction, it is like this, right? If this one undergoes Clemmensen reduction, I will get, okay, so here this is wrong, sorry, this one will give you what? Methane. Okay, CH4. Answer is methane here. Okay. Next, complete the following reactions. So three reactions, 3 mark you will get. Next, the pKa values of acetic acid, benzoic acid, and trifluoroacetic acids are given to you respectively. Arrange them in the increasing order of the acidic strength. Okay, increasing order of acidic strength. This is very easy question, 2 marker, and this is 3 marker. Okay, let us do the first part here. One second. Yes, first we have to complete the reaction, right? So it is, you can easily see carbon dioxide is there. So what will happen? So I can put A1. So you have here CH3 MgBr treated with CO2. So what will happen? This is plus, this is minus, this one will attack here, this one will come here, this one will come here, and MgBr will be taken. So I will get CH3C, okay, double bond O, then I have OMgBr. Then if you do hydrolysis, what will happen? You will get CH3COOH. Okay, next, second one, if you see what I will get, CH3COH with SOCl2. So I have this one, CH3COH with SOCl2. So what will happen? This OH will get converted to Cl. So you will get acyl chloride here. Apart from that, we'll get bioproducts as SO2 and HCl. Next, third one, CH3COH plus NH2, NH3, and then you have to heat it. So what I will get here, see, you have this one and you are treating it with ammonia. So what will happen? This is an acid, this is a base, right? So what it will form? First we will get a salt here, that is CH3COO minus and NH4 plus. After that, when I heat it, what will happen? One H2O will be removed here and we will get an amide as the product. Okay, clear? 3 reactions will get 3 marks. Next, arrange the following. So you have first of all acetic acid. Okay, let me just write it as 1. Then I have benzoic acid, which is 2. Then I have trifluoroacetic acid. Trifluoroacetic acid. So here what I have, there 0.476, this is 4.19, and this is 2.3. So already their pKa values are given, and we know that lower the pKa values, higher is the acidic strength. So you have to write that point first. So this is answer B. So first you have to write lower the pKa value, stronger the acid. Right? Now, which is having, so you have to write it in the increasing order, means the lowest one to highest one. So this is having the highest pKa value, means it is the least acidic one, right? So I can write here acetic acid. After that I will have benzoic acid, and next I have trifluoroacetic acid. Now here they haven't asked you the reason, but you can easily see the reason here. We have here CF3, a very strong withdrawing group, so that is why the acidity increases here. Okay, let us see the next question, that is question number 20. So this type of question is also very popular. So let us see. An organic compound X with molecular formula C7H. So here's a small error. Okay, this is C8. C8H8O forms an orange-red precipitate with 2,4-DNP reagent. Now let us see up to this one. When we have only one oxygen, what all functional groups we can think? We can think alcohols, ethers, aldehydes and ketones. But now when it is saying that it is reacting with 2,4-DNP, that means it can be either aldehyde or a ketone group. So I have this one C8H8O, okay, that is your X, which is a aldehyde or ketone. Next, let's read the statement. And gives a yellow precipitate on heating with iodine in the presence of NaOH. So if it is giving you a yellow precipitate, I can conclude that what it is, it must have a CH3CO group, that is your haloform reaction. Okay. Okay, next, it neither reduces Tollens reagent, that means it is not an aldehyde, so we can definitely say that it has to be a ketone group. Okay, so now whenever you have a carbon more than the 6 and it is a ketone group, every time you might first think of an option where there is a benzene ring involved. Okay, carbon number more than 6 and hydrogen number is also same as that of carbon, then definitely it has to be a benzene ring. So what I can guess here is the X group must be COCH3. Okay, so this is your X. Now what is it doing? The first reaction is with 2,4-DNP, so I can write it like this, H2N. Okay, then I have this one and I have NO2 group here and NO2 group here. So what will happen? This O and H2 will be removed, so I'll get a structure like this where I have CH3 double bond N, and here I have a benzene ring, here I have NO2 and here I have NO2. Okay, after that what is there? Next one, it is getting reacted with iodine and NaOH. So you will get I2 in presence of NaOH. So here what will happen? We will get a compound like this, COO minus Na plus and CHI3. Clear? This is your second reaction. Next, on oxidation with chromic acid. So if I am oxidizing with chromic acid, this one will get converted to benzoic acid, right? And this is your Y. And if you see here, we have C7, the C7 is there, H6 is there, 1, 2, 3, 4, 5, 6 and O2. So this is your benzoic acid. Okay, clear? So these are the important questions. Next we will see between methanol and ethanol which could undergo aldol condensation, write the chemical reaction involved in it. So you know, for aldol condensation we need alpha hydrogen, right? So I can write here, just a minute. So I can write here, let's see the question number 21. Between methanol and ethanol which would undergo aldol condensation, write the chemical reaction involved in it. So first of all I can write here that ethanol will undergo, right? Ethanol will undergo aldol condensation due to the presence of what? Alpha hydrogen, right? Due to the presence of alpha hydrogen. And you also have to write the reactions that is involved in this one. So if I have ethanol, okay, so you have CH3 CHO in presence of dilute NaOH. Okay, so I'll just write down the product directly. I have taught you a trick many times, right? So you can write down the two reagents like this, connect this one here, remove one hydrogen here, add that hydrogen here, remove this double bond, and next you can put a double bond here. So I will get a product like this, CH3 CH double bond CH and then COH. Okay, so yes, we got this one. Next what I have, write the chem. How do you convert propanol to propane and write the reaction? This is also very simple. Propanol to propane by reacting with, you can simply write by reacting with ZnHg, that is your Clemmensen reduction, ZnHg and HCl. So I have propanol, right? I can take like this propanol, and then if I treat it with zinc, amalgam and HCl, so this one will give you propane. Okay, next write the reaction and the name the products obtained when acetophenone reacts with sodium hypochlorite. Explain the formation of anhydride from carboxylic acid with an example. So let us first see this answer. So carboxylic acid on heating with H2SO4 or P2O5 gives you anhydride. So you can see we have carboxylic acid. So here there will be dehydration, water will be removed and we will get anhydride here. Next, what is there? The next thing we have to find out, the first question is the reaction of acetophenone. So if I have acetophenone okay, with sodium hypochlorite. So I can write like this, NaOCl. So what will happen? This part will convert it to CHCl3, that is chloroform, and this part will get converted to salt. So I'll get, okay. Next we'll go to amines chapter. Okay, so here also the questions are very limited, like Gabriel thalamide. Okay, some important questions I'll be showing you. The first one, give the preparation of para-hydroxy azobenzene, that is your coupling reaction. pKb of aniline is more than that of methenamine, give reasons. Okay, so pKb of aniline is more, that means aniline is less basic. So what I can see here, the first one, so benzene disonium chloride reacts with phenol, in which the phenol molecule at its para position is coupled with the disonium salt to form para-hydroxy azobenzene. Okay, so reaction you can see, statement you can see, it will give you 2 marks. Next, pKb of aniline is more than methenamine, give reason. Okay, so the pKb value of aniline is very high. Why? Because in aniline the NH2 group is attached directly to the benzene ring. It results in the unshared pair of nitrogen, unshared electron pair on nitrogen atom to be in conjugation with the benzene ring, and thus making it less available for protonation. So if you see like this, aniline is this one, right? The lone pair of aniline is in resonance with the ring, so it is not available for donation. That is the first thing. Now what happens if it is behaving as a base? It will accept a proton. So once it accepts a proton, what it will form? It will form anilium ion. So you can see the conjugate acid formed anilium ion has only 2 resonating structures, whereas aniline has 5 resonating structures. Therefore aniline is more stable than anilium ion. So why will it get converted to anilium ion? Because aniline itself is more stable. So you can see the resonating structures of aniline. This is anilium after it has behaved as a base. So the after it has becoming, this is conjugate acid, right? One second. Yes, this is conjugate acid. So if the conjugate acid is very stable, the base will be stronger. But here conjugate acid is less stable. Why? Because it has only 2 resonating structures. So that is why aniline is a weaker base. Okay. Next we'll see, write the general equation involved in the Gabriel thalamide synthesis for the preparation of primary amine. This is very common and important reaction. Explain carbyl amine reaction with an equation. This is also important reaction. Arrange the following in the increasing order of their basicity. Okay, so let us first see the B part, carbyl amine reaction. So aliphatic or aromatic primary amines on reaction with chloroform, that is CHCl3, and ethanolic potassium hydroxide forms isocyanide or carbyl amine, which are foul smelling substances. It is used for a test of primary amines. So you can take RNH2 plus CHCl3 in place in KOH will give you RNC, which is a isocyanide, a foul smelling smell, and use as a test for primary amines. Next, arrange the following in the increasing order of their basicity. So if you see here, CH3NH2, the primary amine, it has plus psi effect, it will donate the electron, so that will be more acidic, then ammonia, and lastly it will be aniline. Just now we have seen that the anilines have very higher pKb value. Now coming to Gabriel thalamide synthesis. So thalamide on treatment with ethanolic KOH produces potassium forms potassium salt of thalamide, which on heating with Rx with alkyl halide followed by alkaline hydrolysis gives you the corresponding primary amine. So you can see this reaction, this definition that you have to mark. This will give you 2 marks, 2 marks, 1 mark. Okay. Next, question number 25, what is Hinsberg reagent and how do you distinguish between primary, secondary and tertiary amines using Hinsberg reagent? That is the first thing. Explain Hofmann-bromamide degradation reaction by taking butanamide as an example. Give the IUPAC name of the product. Okay. So let us see here, first of all, amides on treating with bromine and aqueous NaOH gives you primary amines. This reaction is called as Hofmann-bromamide degradation. So first part is over. Next, when you have to take butanamide as an example, so you have to take that only, you cannot take any other thing. So it is like this. Okay, so this is butanamide. When I treat it with Br2KOH, this part will be vanished and I will get this one, I'll get, and this one is having 3 carbons, so it is called as propanamine. Okay, right? So IUPAC name of the product is also over. Next, what is Hinsberg reagent? So benzene sulfonyl chloride is known as your Hinsberg reagent, and how it is used? So see, primary amines react with Hinsberg reagent to form N-alkyl benzene sulfonamide, which is soluble in alkali, okay, due to the presence of acidic hydrogen. So first of all, what happens? You have taken primary amine benzene sulfonyl chloride, you get a salt, and this salt is soluble in alkali because of this hydrogen present. Now when you take secondary amines, what will happen? Secondary amines react with Hinsberg reagent to form N-dialkyl benzene sulfonamide, which is insoluble in alkali due to the absence of acidic hydrogen, and tertiary amines does not react at all. Okay, clear? Next, we have here an aromatic compound A on treatment with aqueous ammonia and heating forms a compound B. Okay, so let us see an aromatic compound A on treatment with aqueous ammonia and heating forms a compound B, which on heating with Br2 and KOH forms a compound C of molecular formula C6H7N. Okay, so let me think this one. Write the structure and the IUPAC name of compound A, B and C. Okay, I have an aromatic compound A, okay, which on treatment with aqueous ammonia and heating forms a compound B, aqueous ammonia, okay, and heating forms a compound B, which on treatment with Br2 and KOH gives a compound C of the molecular formula C6H7NH2. So this I can easily guess it is your aniline, right? So 1, 2, 3, 4, 5, 6, 7 NH2. Now if you are treating it with bromine and KOH, then this must be your Hofmann bromamide degradation. So this must be like this, and this one can be obtained if I have taken here carboxylic acid. Okay, so here what will happen? Here what will happen? Here NH2 will be removed, like we'll get NH2 after heating, you will get amide, and this one is there. So write the structures and the IUPAC name of A, B and C. So A is what? Benzoic acid. Okay, here it is benzamide, and this one is aniline. Written. So you will get 3 marks here. Next, give reason. During the reduction of nitro compounds to amines, scrap iron and hydrochloric acids are preferred. Solubility of aliphatic primary amines decreases with the increase in the molar mass of the amines. So first of all, why do we use scrap iron? So that is there. So reduction with iron, scrap and hydrochloric acid is preferred because the FeCl2 formed gets hydrolyzed to release hydrochloric acid during the reaction. So FeCl2 is formed, again this one gets hydrolyzed to give you HCl. Thus only a small amount of hydrochloric acid is required. Okay, so this hydrochloric acid can be regenerated if we use scrap iron. That's the reason. Next, solubility of aliphatic primary amines decreases with the increase in molar mass. Yes, because due to the increase in size, the hydrophobic part also increases, and that leads to decrease in the solubility. Okay. Next, amines act as nucleophiles or amines behave as a Lewis base. Give reason. So that is due to the presence of lone pair of electrons on nitrogen. So you can see here. Next, aliphatic amines are stronger bases than ammonia. Give reason. Why? Because due to the plus I effect. So you can see here you have ammonia, okay, and you have amines, aliphatic amines. So here what will do? This R group will donate electrons, electron density will increase. So that is why it is a better base. Aromatic amines are weaker base than ammonia, because again, if in case of here, if I take aromatic amines, that is your aniline, its electrons are involved in resonance, not available for donation. Arrange primary, secondary and tertiary amines in the increasing order of their basicity in gaseous medium. So gaseous medium, it is 3 degree, 2 degree and 1 degree. Next, arrange the following in the decreasing order of basicity in the aqueous medium. R is methyl group. So for methyl group it is 2 degree, 1 degree and 3 degree, right? 2 degree, 1 degree, 3 degree, and then lastly we have ammonia. Next we'll see question number 28. An aromatic compound A on treatment with, okay, this the same question, right? Yes, sorry. Okay, okay, this first part is same, which I have already discussed. Second part I will discuss. Aliphatic amines of lower molecular mass are soluble in water, that is due to hydrogen bonding. Methyl amines is more basic than triethyl amine. Okay, this is important question. Okay, so let us see here. First, lower aliphatic amines can form strong hydrogen bonding, so that is why they are soluble in water. Now if you say methyl amine, that is CH3NH2, and I have triethyl amine. Okay, so you should think that there will be more plus I effect, more donation of electrons, so this should be a very good base. But if we see, methyl amine is a very stronger base than triethyl amine. What is the reason for that? You can see here, methyl amine is more basic than trimethyl amine, sorry, not triethyl, it is trimethyl. One second. Yes, pen. Trimethyl amine, right? So what is the reason for that? To create, because of this big groups, what happens, a lot of steric hindrances there, and due to this steric hindrance, these electrons cannot donate the electrons, this nitrogen cannot donate its electron properly. So this is because the 3 methyl groups attached to the nitrogen atom in trimethyl amine creates steric hindrance, making it harder for the nitrogen to donate its electron as a base. Okay, so this question is important. Next, question number 29, give the IUPAC name of this one, CH3(3)N, that is trimethyl amine. Next, name the major organic product formed in the following conversions. Tertiary amines cannot be acylated. Why? So these are the 3 questions. Let us see here. First, IUPAC name, so it is NN-dimethyl methanamine, right? NN-dimethyl methanamine. When nitrous acid is treated with methyl amine, so you will get alcohols, right? You will get methanol. You have to write the major product here, major organic product. So that is your methanol. Next, benzene disonium chloride is treated with Ki. You will get iodobenzene. Okay. Next, tertiary amines cannot be acylated. Why? Tertiary amines cannot be acylated. Why? So if you see, in case of acylation, what happens generally? So if I have like this R NH2 and I treat it with any acyling group like CH3COCl. So what will happen? H and Cl will be removed and you will get RNHCO and CH3. Okay, so what is the requirement here? The nitrogen here should have a hydrogen present which can be replaced with this chlorine group. So but in triethyl or tertiary amines there is no hydrogen here, so it cannot undergo this reaction, right? That is very simple reason. The tertiary amines cannot be acylated because they lack a replaceable hydrogen atom on the nitrogen atom, which is necessary for the formation of an amide bond during the acylation reaction. Okay, so this bond cannot form if there is no hydrogen here, right? So that is the answer. Next, question number 30, give the preparation of para-aminobenzene. So like we have coupling reaction for para-hydroxy, similar way you have to write same reaction, just you have to convert or you have to change phenol with aniline. Okay. Next, an organic compound P with the molecular formula C6H7N with treated with acetic anhydride in presence of pyridine to give compound Y. Okay. So let me first see, I have P here which is having C6H7N. Okay, I can think this is aniline. Okay, treated with acetic anhydride. Okay, in the presence of pyridine to give you compound Y. Okay, the compound Q undergoes bromination. Okay, bromination with bromine in acetic acid to give a substituted amide R. Okay. The compound R on acid hydrolysis, okay, yields a substituted amine S. Okay, write all the reactions involved. Okay, so this I can easily think all of you know how to protect the aniline and then do bromination and then deprotection. So that is what is given here. So what is P? P is nothing but aniline. Then you are treating with an acetic anhydride. So that is okay. So that is your acylation of the aniline to give you NHCOCH3. Next, if I treat it with bromine in presence of CH3COOH, so that will give me bromine in the para position. Okay. After that, what will happen? If I do hydrolysis, this one will be replaced with your amine group NH2 and Br. Clear? So that is what will be the answer, P, Q, R and S. Clear? Okay, now we'll move to the last chapter, biomolecules. Some important questions from this chapter. So first of all, what does tertiary structure of protein represent, and write its two major molecular shape. So this one will give you 2 marks. Write a reaction to show that glucose contains 5 OH groups. Okay, so this is your first one, and there was another part also here to give you, I think, aldehyde group. This carries 2 marks, and zwitterion structure of glycine 1 mark. Okay, so let us see first one. Tertiary structure is the further folding of the secondary structure, secondary polypeptide chains. And what are the shapes that we see? Fibrous and globular. So first reaction is for 5 OH groups, that is you have to react with acetic anhydride. You will get this one where we can see 5 OH groups. Okay, next zwitterion structure in acetic. So here there was one more question, that the reaction which can show aldehyde group. So that I can do here. So if you react with like this, I will write CH2OH, and if I react it with bromine water, what I will get? I will get gluconic acid. Okay, so that reaction gives me that there is an aldehyde group present here. Okay, next zwitterion structure. So glycine, if you know, it is C, you have H, you have H, you have COO minus and NH3 plus. That is the zwitterion structure of glycine. Next, what is peptide bond? How many peptide bonds are there in a pentapeptide? So peptide bond, all of you know, a protein are the polymers of alpha amino acid, and they are connected to each other by a peptide bond or peptide linkage. Chemically, the peptide linkage is an amide formed between the COOH group and the NH2 group. Okay, that is your peptide bond. Next, how many peptides are there in a pentapeptide? Means there are 5 amino acids, so there will be 4 peptide bonds. Next, write the Harvard structure of maltose. So Harvard structure of maltose, you can see here. This is the structure of maltose. You should remember the structure correctly. Name the protein present in here, that is your keratin. All of you might be knowing this one. Okay. Next, what are reducing sugars, and give example. Name the naturally occurring optically inactive amino acid. Name any one vitamin that is stored in liver and adipose tissue. This is also very simple question. Reducing sugars are those sugars which can reduce to the Fehling solution or tolerance reagent. Example, there are many: glucose, galactose, fructose, maltose, lactose. Okay, so these are the reducing sugars which contain a free aldehyde or a keto group. Next, naturally occurring optically inactive amino acid is your glycine, and the one which can be stored in the liver and adipose tissue are your fat soluble vitamins like A, D, E and K. Okay. Next, what are anomers, and give an example of a ketose sugar. Give 3 limitations of open chain structure of glucose. Okay. So what are anomers? Sugars which differ in their configuration at C1 position are called as anomers. Next, give an example of ketose sugar is your fructose. Give 3 limitations of the open chain structures. The first one is it does not give positive test with Skiff reagent, does not react with NaHSO3. Second one is the penta-acetyl glucose does not react with hydroxylamine. Okay, and the third one, it exists in the alpha and beta form. So these are the 3 limitations that you should be writing for the open chain structure. Next, draw the Harvard structure of lactose and what is denaturation of protein. Give an example. Give an example for a water soluble protein. Okay, so Harvard structure of lactose, simply you have to draw it. Okay, just draw it and do all the leveling here. Next, denaturation of protein. So the loss of biological activity of a protein when it is undergoing a change in the pH or the change in the temperature, that is called denaturation of protein. Example also you have to give. So during the denaturation, the primary structure is intact, that you should remember. Example is coagulation of egg and curding of milk. Next, water soluble proteins. Oh, sorry, not protein, water soluble, yeah, water soluble proteins. Okay, sorry, here I have given wrong example, that is not white, it's not. Water soluble proteins are your globular protein. Globular protein. Water insoluble proteins are your globular protein. Okay, so example you can write here albumin, whereas fibrous proteins are water insoluble. Okay, next, what are essential amino acids? Essential amino acids are those which cannot be produced in the body, has to be taken from the diet. Example you can write, there are 10 essential amino acids. 3 differences between RNA and DNA. Okay, this is very simple question. So first of all, examples you can see valine, leucine and lysine. DNA and RNA, it is double stranded, single stranded. Here what all sugars are used, that I will write. So here we have deoxy ribose sugar, right, and here the sugar used is ribose sugar, it is not deoxy. Here what are the bases we have? A, T, G and C, adenine, thymine, guanine and cytosine. Here we have A, U, G and C. Clear? Okay, next we will see question number 37. What are oxidoreductase enzymes? Name the enzyme that catalyzes hydrolysis of maltose into glucose. 2 marks. Give any one main natural source of vitamin K. Give reason sucrose is a non-reducing sugar. What is invert sugar? Okay, so many good questions are here. So oxidoreductase enzymes are those enzymes which catalyze the oxidation reduction reactions. Okay, so the enzymes which catalyze the oxidation of one substrate with simultaneous reduction of another substrate is named as oxidoreductase enzyme. Next, which enzyme catalyzes the hydrolysis of maltose? That is your maltase enzyme. Next, give any one main natural source of vitamin K, that is your green leafy vegetables. Next, give reason sucrose is a non-reducing sugar. So sucrose does not have a free aldehyde group, so it cannot reduce your tolerance reagent and Fehling solution. So that is why it is a non-reducing sugar. Next, what is an invert sugar? See, sucrose is a dextrorotatory compound. Dextrorotatory means what? It will rotate the plane polarized light in clockwise direction. Now, if you put some acidic water in sucrose, it will undergo hydrolysis and it will break into glucose and fructose. Now, fructose is levorotatory, glucose is dextrorotatory. Fructose is more levorotatory than glucose. So earlier when only sucrose was there, the light was rotating in clockwise direction. When you, after some time, due to the hydrolysis, fructose and glucose is produced, now the solution is levorotatory. Okay, so now earlier it was dextrorotatory and now it is levorotatory, and that is called as inversion. Okay, so you can see sucrose is dextrorotatory, but after hydrolysis it gives dextrorotatory glucose and levorotatory fructose. Since the levorotation of fructose, that is minus 92.4, is more than the dextrorotation of glucose plus 52.5, the mixture is levorotatory. Thus hydrolysis of glucose brings about a change in the sign of rotation from dextro to levo, and the product is named as invert sugar. Clear? Okay. Next we have, name the storage polysaccharide present in plants, that is your starch. Name the monomer unit present in starch, alpha D glucose units. Name the component of starch, amylose and amylopectin. Differences between amylose and amylopectin, very important question. You can see this is water soluble, insoluble, 15 to 20%, here it is 80 to 85%, unbranched, and this is branched. C1-C4 linkage, here it is C1-C4 and C1-C6 glycosidic linkage. Okay. Next, okay, so after this I'll be telling you some important things that you should remember in this biomolecules chapter. Is in disaccharides we have sucrose, maltose and lactose. Okay, what is the bonding, what are their monomer units and what is their bonding present? So these table you can draw it, you can remember it, very helpful. And one more thing that you should be remembering from this chapter, most important topics: glucose, all the 5 reactions; disaccharides, their polysaccharides and monomer units, what is reducing and non-reducing sugars, and what is anomers. Okay, in proteins, structure, peptide bonds, zwitterion, essential and non-essential amino acids. Vitamins, fat soluble, water soluble, deficiency disease, very important. Hormones, very important with their functions. Nucleic acids, RNA, DNA difference and the structure. These are the important topics that you must be covering from this particular chapter. Okay, yes. Okay, so yes students, that's all in this video. Most important 5 marker questions I have discussed. So basically if you do 3 and 2 markers properly, it will be a mixture of that, 1 3 marker and 1 2 marker will be taken. So basically this is a very scoring predictable section. So please make sure that you practice all these questions, and if you want extra questions you can practice from our Brahmastra session as well. Okay, so that's all, and if you have any more doubts you can put down in the comment section. I will definitely address to it, and thank you for watching, and do not forget to subscribe our channel.